Hello, in this video we will see about how to calculate this equivalent resistance when resistors are in parallel. So when we take for example two resistors in parallel, the situation is like this. This is the first resistor, it is R1, and the second resistor is R2. These two are in parallel. How can I say these two are in parallel? Because the current entering into this connection of these two resistors, it is divided. For example, this is the source current I. This current, whenever it is coming up to this point, it is divided into two currents like I1 and I2. So, in this manner, we can see. For better understanding of this one, we can redraw this particular circuit. Like this is one resistor, this is another resistor, and these are R1, R2 we have indicated. So when current I is coming, this current I is coming like this and divided into two currents, I1 and I2. So current is divided in between these two. Okay, so we can tell these two are in parallel. So anyhow, our interest is here to calculate the equivalent resistance. So the equivalent resistance from this particular point of view, we can able to take R equivalent. So when we have like this, we know from I is equal to I1 plus I2. This is a current division. Okay, it is a KCL we have applied at this particular node. So that is I is equal to I1 plus I2. But for these two resistors, because these are in parallel, same amount of voltage will be there. That is V. That is V. Okay. So if you consider this entire parallel connection is like a single resistor, this I can be written as V by R equivalent. And that is equal to I1 is V by R1 and plus I2 is nothing but V by R2. Okay. So V by R equivalent can be written as V times of 1 by R1 plus 1 by R2. From this we can tell 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Okay, this is the equation we can able to take when two resistors are in parallel. And if you want R equivalent directly, you need to take the inverse of this one. Okay, so for simply to write this R equivalent, what you will get in the sense R1 R2 by R1 plus R2. If you take the LCM here, okay, you will get R1 R2 and the numerator will be R1 plus R2. If you take inverse of that one, you will get R equivalent directly like this. Now, the sub case of this one will take, that is like when the special case is when R1 is equal to R2. That means both resistors, both parallel resistors are same. Then you will get R equivalent is equal to R1 is a R, R2 is also R. So you will get R squared by, here R plus R is 2R, that means R by 2 you will get. Okay, so extension of this one, I can take like next one is, instead of taking only two resistors, so now I will take some three resistors. Okay, this is R1, this is R2, this is R3, and I need to find R equivalent. Again, the same approach you have to take. So what will you get? I will get 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Like this I will get. Then, if I take n number of resistors, okay, otherwise first we will take when these three resistors are equal, then I will get 1 by R equivalent is equal to 1 by R plus 1 by R plus 1 by R, that is equal to 3 by R. So, what about R equivalent now? Directly I can get R by 3. Surprisingly, the result we can able to compare the previous result and this one. When you have only two resistors are in parallel and these two resistors are same, then R equivalent we got R by 2. Now when you take three resistors are in parallel, then R equivalent is equal to R by 3 we got. So, I can able to estimate when we have n number of resistors like this. N number of resistors, first one, second one, third one, and up to nth one. So what is the value of R equivalent? R by n. Okay, so this is a surprising result we got, and easily we can able to calculate. You no need to calculate first these two, next these two, next these two. Okay, it is not like that. Okay, so when you have this particular idea, analysis we have to do. Okay, by solving several problems, some conclusion we should get. It is not just solving the individual problems. It is about summarizing the problem answers. Okay, so finally we get R equivalent for the connection of n identical resistors, parallel resistors. We will get the R equivalent is simply R is divided with the n number of resistors. N is the number. Okay, n is the number of resistors. So like this we'll get. Okay, thank you.